In recent years, 3D printing has become synonymous with the Nerf hobby. We use them to create blasters, make replacement parts, cosmetic kits, basically everything. But it's important to remember that your printer is a machine, and actually a fairly crude, simple machine. And like any machine, it needs maintenance. So what I'm going to do today is kind of take you through my routine to maintain and clean my printer to make sure that my prints are coming out consistent and that I don't have a critical failure that requires me to replace a part. So the first thing I'm going to do is clear out the big obvious debris, which for me tends to accumulate here back under my bed and in these little side rails down here. They don't really get in the way, but they don't need to be there, so let's get rid of them. Now for a lot of this, I'm going to use this little automotive detailing brush because it can get down into these little cracks and just kind of brush all that stuff out. There, now it's the floor's problem. So now that all the obvious debris is out of the way, the next thing that I'm going to do is take these Allen keys and just kind of go around and make sure that all of the bolts are nice and tight. This is especially important on the rollers because if they're not tight, you will end up with a lot of wobble. And wobble is never a good thing when you're printing. So just kind of give them all a little tight. 3D printers inherently vibrate, which will slowly make all of your screws come loose over time. So this is just a good idea to do once in a while. And then the last thing that I'm going to check up on is follow all of these little wire groups and just kind of make sure that none of them have ripped, that they're not rubbing on anything, kind of wearing down, that might potentially cause a fire hazard. This is more of an issue down here around the bed where the cable moves a lot and might rub up against the frame or against the motors. Now, this isn't something that I do often, but I sometimes like to open up the main board and make sure that no dust or debris is accumulating inside on the board. I have actually printed a fan shroud to help prevent this from happening, but normally this is an open exposed area that debris will just fall right in onto your board. So I am just going to unscrew all of these. If you have an Ender 3 or any other printer where the board is under the bed, be aware that you have to slide this forward to access the screw in the back. Next, I'm going to turn off the power so I don't die, and then kind of lift this lid off. And everything looks good. I don't see any obvious pieces of plastic or dust accumulating in there, so I'm just not going to touch it. So the next thing I'm going to do is take off this fan shroud so that I can clean out the hot end, change my nozzle, and make sure that the fans are not accumulating dust. Alright, so let's get this shroud off and make sure that you set aside all of your screws because they are very easy to lose. And you'll see that there is quite a bit of dust in there, so let's get that off. If you have a can of air, that would also work really well here. I just don't have one on me. Now, I don't know if this shows up on camera, but there's a lot of little wispy pieces of plastic out here in my fan. And if you allow these to accumulate, eventually they will bog the fan down and break the motor because these are not overly powerful fans. So let's just go ahead and pull those out and give that a good dusting as well. Now, the majority of my maintenance tasks are actually here in the hot end, heatsink, and the Bowden extruder assembly. And in order to work on anything here, we need to heat the hot end back up. So I'm going to set this to about 200 degrees Celsius and give it a second. Now, while that is heating up, I am actually going to take off my PTFE fitting here. So I'm going to remove the little clasp and press down on the fitting. And I'm going to inspect the end of my fitting and make sure that there is no charring. Because if it has started to carbonize, then it's eventually going to split and that will be a problem. And everything here looks good. So next I'm going to remove this PTFE fitting so that it can get down into the heating block. So now I'm just going to kind of visually inspect this to make sure there's no obvious debris or issues in there and everything looks relatively clean. So now I'm going to remove the nozzle. Remember that this is much easier when it's hot. But be careful using a metal tool like this because you are contacting a metal heating element and it can eventually heat up and burn you. So be cognizant of your temperature and be careful around the heating block. Also remember that you are doing this backwards, so you are turning this to the right to loosen it, not to the left. And if you have a socket wrench, this is a 7mm socket, which I don't have, so I'm using the one that came with my printer, which is not as fast and not as exciting. So now that the nozzle is removed, I'm going to take my PTFE tube and I'm going to shove it all the way through the heating block until it comes out where the nozzle would normally be, and then back out. And just kind of keep doing that until it's smooth and there's nothing else coming out the bottom. This is to clear out any plastic that may have leaked in between your Bowden tube and the nozzle seal. I use very inexpensive nozzles, so I'm going to go ahead and replace it with one of these. But if you need to keep your nozzle, if it's a higher end nozzle, or you just don't want to be wasteful, then at this point you could probably take a metal brush and kind of clean all this plastic up off of it. You might need to heat it up again to do that. So I'm going to very carefully hand thread this a tiny bit into the heating block, and once it has threaded on a little bit, I will start tightening it with my wrench. Alright, now once it is relatively tight, what I'm going to do is take it and back it up about a quarter turn, and then I'm going to heat my nozzle up to 240 degrees Celsius. And then I'm going to thread this pneumatic fitting back onto the top. And I just hand tighten this generally. It's not really something that comes loose for me, so that's good enough. And then I'm going to take my PTFE tube and shove it all the way down until I can't go down any further, which should mean that it is now contacting the nozzle. Give it a little tug to make sure that it's sealed correctly. And then I'm going to replace this little clip so it doesn't accidentally come loose. So now that my hot end is at 240 degrees Celsius, I'm going to go back in and tighten it that quarter turn. And what this helps do is account for the heat expansion in the block and make sure that it creates a tight seal when it cools back down. This also is then pulling the nozzle up against the PTFE tube and making sure that they're forming a tight seal as well. And you may notice that you can actually turn this beyond your original quarter turn, because now there's all that gunk or anything that might be still in the threads has melted down and you're just good to go. So now I'm going to go ahead and I'm going to manually extrude a little bit of filament, maybe about 20 millimeters, and just make sure that it comes out clear from the nozzle. Alright, it is coming out clear and I don't see any leaking plastic coming in around the nozzle, which is important. Now, what we're trying to do is make sure that the nozzle and the PTFE tube are sealing just like this. Because what will happen is if there's a slight gap, plastic will build up in between the two pieces during retraction, and it will lead to issues like under extrusion, over extrusion, or even plastic leaking all around your hot end. So if you experience any of those things, this is probably your issue. Take it apart, clear it out, make sure the seal is good. There are also a variety of fixes and modifications to your heatsink and heating block that use 3D printed parts to ensure that everything is sealed tightly. So you may want to look into that for your printer if you're encountering those kinds of issues. So now I'm going to throw my printer into cool down mode and put this fan shroud back on with the screws that I definitely did not lose. And then just tighten everything up. And then the last thing that I'm going to do before I actually print out my calibration prints is apply a small amount of super lube on the Z-axis lead screw. So what I'm going to do is move my Z-axis all the way down and just kind of apply it all around the base of the gear, and then just run it up and down. This makes sure that it gets all over the gear. My printer only has one, so this is pretty easy for me to do, but if you have multiple, just make sure that they're lubricated as well. Now, anytime that you do anything with your hot end, you're going to want to re-level your bed. If you have an auto leveler, then great, go through that process. And if you don't, then bring everything on the bed down a bit to make sure that you don't accidentally scrape the bed. And then bring it back up until you can fit something about the size of a piece of paper or a playing card between the bed and the nozzle. So I am going to do that now. Then I'm going to take some isopropyl alcohol and just kind of wipe my bed down Make sure there's no dust and debris on there from the cleaning process. Now, my calibration print, which I will link in the description below, prints squares in each of the corners and in the center of my bed. And what I'm going to do while it prints is just kind of monitor it, and if it's coming out a little thin, I will move my knob up, and if it's not coming out enough, I'll move my knob down and just kind of make on-the-fly adjustments until the corners look the way that I like. Then I'll run it one more time, and after that, usually everything is good. And that's about it. I do these tasks about once a week. I dust more frequently if it's dusty or if I've been doing something in the garage that creates obvious dust, like cutting wood or something similar. However, I only replace my nozzle maybe once a month unless something happens and I need to replace my nozzle because it needs to be replaced. Yeah. Now, if you're having any specific issues with your prints that maintenance is not correcting, I'm going to link a subreddit below called Fix My Print, where you can post a picture of the issue that you're having, and the people there will kind of analyze it and tell you, hey, that looks like under extrusion or over extrusion, or it looks like your Z-axis might be a little out of alignment, so on and so forth, and you can take that information and figure out how to address that for your printer specifically. I will link that below. And if you have any tips for me to maintain my printer or any questions about the maintenance that I'm doing, leave me a comment below. If you thought this video was helpful, please leave a like. Feel free to subscribe for more content in the future, and thank you for watching.